All right, Unit 6, Day 1. Let's go through these notes. If you have trouble with any of these concepts, feel free to pause, rewind, watch again. And if you aren't feeling comfortable with the material, please reach out, send me an email, write to me in Google Classroom, whatever you need to do. But I will be monitoring all of the communications frequently. So, okay, let's start it right off with some product rules of exponents. You did this in Algebra 1, and you learned that when you multiply two terms that have the same bases, so for example, both of these terms have a base of x. So make sure that we clarify this. If I have something such as x to the second power, the x is called my base. And in this case 2, the raised number is called the exponent. Right? So when I talk about the base or the exponent, that's what I'm talking about. The base is the lower number, and then the exponent is the raised number. Okay? So with that in mind, we take two numbers that have the same bases, in this case, base x times base x. And the rule is that when we multiply the two terms, we add their exponents. So x to the power of m times x to the power of n is equal to x to the power of m plus n. Okay? Now, if that doesn't seem clear, I think when we do these two examples below it, it will clear up. So let's see. So w to the fourth power times w squared, or w to the second power, will equal w to the power of, okay, look at our rule, that would be 4 plus 2. And then all you have to do is add 4 and 2. So your answer is w to the sixth power. Okay, easy peasy, right? So let's do the second one. So we have d to the fifth power times d. So remember, invisible math, there is an exponent there. We just didn't write it. So it's d to the first. So it's d to the fifth times d to the first, which will equal d to the power of 5 plus 1, which is d to the sixth power. So d to the fifth times d gives us d to the sixth. Okay. So let's scoot this page up just a little bit. All right. So we're going to use the same rule when we multiply the base times the like base. So if you look at this next example, we have x times x to the 8th. Okay, so let's just take that part for a second. So x to the first times x to the 8th is x to the power of 1 plus 8, which is x to the 9th. Okay, so if we remember that, the rest of this should fall in line pretty nicely. The numbers in front, the coefficients, we got positive 9 and we got negative 3. Okay, so I break it down one step at a time. First thing I ask is, what is the sign of my answer? Okay, so we got a positive 9 times negative 3. So that means that my answer is going to be negative. Positive times negative is negative. The second thing I'm going to ask is for you to multiply the coefficients, the constants, the numbers. Okay, I'll just say the coefficients. So 9 times 3 is 27. So step 1, we figured out the sign is negative. Step 2, 9 times 3 is 27. And then step number 3, is to multiply the variables. And I'll erase that in a second, but multiply the variables. So we did that. X to the first times x to the 8th is x to the 9th. So this is my final answer for this question. So 9x times negative 3x to the 8th gives us a product of negative 27 x to the 9th. Right? So let's look at this next example. Right here, question 2. No, let's do our 3 steps. Step 1, what is the sign? Well, it's negative times negative. Negative times negative is a positive. So we have a positive. Step 2, multiply the coefficients, multiply the numbers. We got 5 times, there's a 1 there. It's another invisible math question. It's like negative 1y to the 4th. So 5 times 1 is 5. Step 3, multiply your variables. Well, we got y's, which are like bases. So y to the 4th times y to the 4th is y to the 4 plus 4 power, or y to the 8th. Okay? Now, we don't need to have a plus out in front in order to say positive. If you keep it there, I'm not going to call it an incorrect answer. But the answer is positive 5y to the 8th. Okay? All right, so let's go down to the next little group. And this next little group here has 3 terms. We're going to do the same rules. We're going to keep it the same order. It's just we're going to multiply 3 things at a time instead of 2. So step 1, what sign is my final answer going to be? Well, the first term is positive, and the second term is positive, and the third term is positive. So positive times positive times positive is going to equal a positive answer. So my positive answer is step 1. My second step, multiply the coefficients, multiply the numbers. 4 times 3 times 2. Well, 4 times 3 times 2 is 24. Next step, multiply all of the variables. So we start with w to the 6th. Are there any other w's to multiply? Yes, there are. There's a w to the 8th. Well, I can multiply those together. So that's w to the 6th plus 8th power, which is w to the power of 14. And then there are u's. There's a different base. There's u to the 1st times u to the 7th. So u to the power of 1 times u to the power of 7 is equal to u to the power of 1 plus 7, which is u to the 8th. Okay, so it's positive, it's a 24, w is going to be to the 14th, u is going to be to the 8th. Now, this is a good answer right here. I have no problem with that answer. I would give you full credit. You want to get elegant, you want to get precise and nice, then first off, you don't need the plus. 24 is going to be 24. And then we like to keep the letters in alphabetical order. So since U comes before W in the alphabet, if you want to give an elegant answer, then put the U first. So it'd be U to the 8th, W to the 14th. Okay. Again, I like this answer. I like this answer. Okay. It's just one's a little more refined than the other. It's not that one is more or less correct than the other. Okay, so question 2. Step 1, what is the sign of my answer going to be? So again, positive times positive times positive, it's going to be positive. So at this point, if you want to put the plus there, great. I'm not going to write the plus on this one because we just know it's positive, and I'm going to end up taking away the plus sign anyway. So we've got x's and y's. Okay, so let's take the x's first. X to the 9th times x to the 9th is x to the 9 plus 9 power, so that's x to the 18th. Well, let's not forget the coefficients. I skipped it, so my fault. The coefficients are 4 times 5 times 2. Well, 4 times 5 times 2 is 40. So let's get that 40 in there in front of the x to the 18th. So 40, and then we've already done the x's, x to the 18th. And then what about the y's? We got y to the 8th times y. Remember, there's an invisible 1 above in the exponent. So y to the 8th times y to the 1st is y to the 9th. Good answer. Okay. I'm going to scroll up some more. So that concludes the multiplying part of day 1 notes. This next little part, I think you'll find kind of nice and easy, is just taking a polynomial, which is a group of terms in an algebraic sequence here. And it just asks you what's the degree of the polynomial and what is the leading coefficient. So let's just do a couple of these and you'll see what those are and how they are found. Okay. So first it says, what is the degree? Well, the degree is talking about the exponent. Like x to the 3rd is a 3rd degree term. X to the 5th would be a 5th degree term. Well, it says here the degree of the entire polynomial, okay, the entire algebraic sentence, is just the highest exponent of the variable. Right? So if you look here, 10 doesn't have the variable written behind it. So that's like saying 10x to the 0. 7x doesn't have an exponent written, but there is a variable there. So there's the invisible 1. So that term has x to the 1st. That's a 1st degree term. And then we have x to the 8th, which is an 8th degree term. So the first term is a 0 degree. The second term is a 1st degree. The third term is an 8th degree. So in order to know what the degree of the polynomial is, all you have to say is which one is the highest. So this polynomial is an 8th degree polynomial. Hopefully you're saying, well, that's pretty simple. Good. I'm glad. That will make the second one easy as well. Because now if they say, what is the leading coefficient? They say, what is the leading coefficient? Well, leading obviously is something that's in front of something else. And the coefficient means the number in front of the variable. So all you have to do is take the term that had the highest degree. So which term had the 8th degree? Well, obviously it was this one. And you say, what number is in front of that x to the 8th? You say, well, there's a negative sign. And again, invisible math. There is a 1 in front of an x to any power. So your leading coefficient is -1. And that's it. That is your example. Easy peasy. So let's look at the second one. The second one, we have 1, 2, 3, 4 terms. The first term is 20y, or 20y to the 1st. So this one has a 1st degree term. Second one is a 5th degree term because it's y to the 5th. Then you've got y to the 8th. That's an 8th degree term. And then the term that doesn't have any x is x to the 0. So that's a 0 degree. So out of all of these, we look at the degrees and we say the largest one is 8. So it is an 8th degree polynomial. This whole polynomial is an 8th degree because the largest exponent on a variable is an 8. Now you take this term and you say, what is the leading coefficient? Well, what is it? It's the number in front of that y to the 8th. The number in front of the y to the 8th is a negative 23. And yes, you need to have the negative. Okay, if you just write 23, it is incorrect. Okay, so that is leading coefficients and degrees of a polynomial. Let's go to the next page. So we have multiplied terms that had variables in them. We have recognized now leading coefficients and degrees of polynomials. The last thing we're going to do is we're going to add and subtract polynomials. So right here we have a quick reminder that you can add and subtract like terms. We often said combining like terms, CLT. And a lot of people just know the initials, CLT. When are terms like terms? Well, they are like terms when they have the exact same variables okay? So if one term has A, B, the other term, in order to be a like term, must have A, B. If one term has X and the other term has Y, they're not like terms. If one term has X and the other one doesn't have X, they're not like terms. If one term has A, B, C, D, and the other term just has the A, the B, and the C, they're not like terms. They have to have the exact same variables. And those variables must have the exact same exponents. So for example, if I had 5x to the third, and I had 7x to the third, well, they both have x, and they both have x to the third. So those are the two requirements that you need. If I had one of the terms had x to the third, y to the second, and the other term just had x to the third with no y, or even if it had like y to the fifth, I cannot add or subtract those two terms. They're not like terms. Why? Because they have the exact same variables, but they don't have the exact same exponents with those variables. So those are not like terms, right? The little example that is given to you over here, you have 3x squared and negative x squared, or negative 1x squared. So if you look at those, you say they both have x, and those x's both have 2 for the exponent. So yes, they are like terms. I can add them, I can subtract them. And that's what you can do with like terms. So let's look at that. Let's add two polynomials. We have first polynomial, second polynomial. All right, so you can only add the like terms. So I like to make sure that I keep track of when I have used any of these terms. So for example, if I use this v squared, I'm going to put a mark under it. So v squared, and I'm going to add the like term in the second set of parentheses. So that's a negative 5v squared. So you have 1v squared, and we can put the work off to the side if you'd like. You have 1v squared plus 5v squared. Okay, you don't need to put that off to the side, but you should know that that is 6v squared. Okay? So my first term in my answer is going to be 6v squared. Now the second term here is a minus 6v, and there is a like term over here, plus 7v. So negative 6v plus positive 7v. Well, if you add those together, negative 6 plus 7 is 1. So that's just v, 1v, and it's positive. So I know in my answer, there's a plus 1v. And then finally, there's a plus 4 and a plus 3. So positive 4 plus positive 3 is a 7, and it's positive, so plus 7. And that is my sum, my SUM, sum of those two polynomials. So I used all three of the terms in the first set of parentheses. I used all three of the terms in the second set of parentheses. So there isn't a term that just hasn't been used. If there were a term that I didn't underline, I'd have to bring it down and add it in here somewhere. Like if there was an x that didn't have another x to add or subtract, I'd have to bring it down into my answer. Okay, so I took the like terms, I added them together, I have my answer. Okay, so let's look at the second one. The second one, this one's more difficult. Okay, I'm telling you, this one's more difficult. I'm giving you the quick heads up. And the reason this one's more difficult is because of this. It's subtraction. Now, if you thought addition was easy, and I would agree with you, it's easier, much easier, then my first step for this second question is, let's make it an addition question. And how do we do that? Well, we're going to copy the first polynomial, and then we're not going to say minus anymore. If you remember, 3 minus 1 can also be written as 3 plus negative 1. So we're not going to subtract the second polynomial. We're going to add its opposite. So it's like a distributive property. There's a negative 1 outside of the parentheses, and we're going to take that negative 1 and we're going to multiply it by the 7v squared. We're going to multiply it by the 5v. We're going to multiply it by the 4. We're going to multiply by all of them. So when we do that, we get, let's take it one at a time. Okay, so negative 1 times 7v squared is negative 7v squared. Negative 1 times positive 5v is minus 5v. Notice all we're doing is changing the sign, okay? And then negative 1 times positive 4 is minus 4. Okay, so now we have an addition question. Now it's just like example 1. Cool, right? So now let's do like terms. So let's add 2v squared plus negative 7v squared. Okay, and again, we can write it off to the side if we want to do the work. 2v squared plus, make that a little bit, plus negative 7v squared. Well, 2 plus negative 7 is negative 5. So that's negative 5v squared. So I know in my answer, I have a negative 5v squared at the beginning. Okay, next term, positive v. We're going to add negative 5v. So v plus negative 5v. Okay. So from that, 1 plus negative 5 is negative 4, so that's minus 4v. minus 4b. Okay, well, what's not underlined? Well, we got positive 3, and we got negative 4. So 3 plus negative 4. 3 plus negative 4. Well, 3 plus negative 4 is negative 1. So we got minus 1. And there's our answer. Okay. Pause this. Go back. Look at this question again. Make sure that you get all your steps. Okay. Step 1. Change the subtraction question to addition. Step 2. Combine like terms and mark underneath when you have used the term up. I don't like crossing it out, because what happens if you cross it out in pen and then you go, oh, I made a mistake, and you have to go back. And then it's just a pain in the rear, right? You don't want that. Okay, so you have done adding or subtracting two polynomials. Our last step for today is we're going to take 1, 2, 3 polynomials and do a little adding and subtracting there. So let's scoot this up. Oh, that looks lovely. All right, so we're going to take this 3 polynomial question, and we're going to do what PEMDAS told us to do back in pre-algebra or algebra 1, whenever you did PEMDAS. PEMDAS said that when you're doing addition and subtraction, or the A and the S, you do it left to right. So let's make sure that we do it 2 at a time. And let's make sure we do it left to right. So what does that mean? It means we're going to take these 2 first, and we're going to get our answer. We're going to subtract them, get our answer. And then once we've gotten that answer, then we can take the 3rd polynomial and we'll add it to it. But don't try to do 3 at once. Do 2 at a time, get your answer, and then do the 3rd one. Like if I said, what is 2 plus 1 plus 5? You say 2 plus 1, 3, and then go plus 5 for your 8, right? You don't have to go 2, 1, and 5 all at the same time. Obviously you can, but I hope you can. But in this case, let's just take it 2 at a time. All right, so we're going to just ignore this 3rd guy for a second, and we're only going to look at the first 2. So this is subtraction. So remember, this is the more difficult one. We're going to change this to addition. So let's do that. So let's change the 2nd polynomial, but we're going to keep the 1st one. So instead of subtraction, we're going to add the opposite. So we're going to distribute that minus sign. So it's going to be minus or negative 5y squared. It's going to be minus negative, okay, which is plus 4y. So notice we're just changing the sign. Change the sign of that positive 5, change the sign of that negative 4, and now we're going to change the sign of that minus 1. It's going to be plus 1. Okay, so easy peasy now, right? We're going to look at adding like terms. We're going to combine like terms. So we start 6y squared plus negative 5y squared. All right, so I'll put my work off to the right here. 6y squared plus negative 5y squared is positive 1y squared. So you can put a 1 there if you want. I'm just not going to. All right. Next up, we're going to take the next term. So minus y. So like negative 1y plus positive 4y. So negative 1y plus positive 4y. Well, negative 1 plus 4 is 3. Don't forget your y. So negative 1y plus 4y is positive 3y. Let's make that a little bit prettier. Now it's debatable if this is pretty or not, but at least you got me verbally saying it, so you can go back and say, what is that anyway? Oh, I'll listen to what he said. Okay, so plus 3 added to plus 1. So plus 3 added to plus 1 is 4. All right, so that is the sum of the first two polynomials added together. Now let's bring down our good friend, the third polynomial. So let's bring him down here. So that's a plus 4y squared minus 3y minus 6. Okay, so let's do the like terms. Y squared plus 4y squared. Y squared plus 4y squared is 5y squared. Because remember, there's an invisible 1 in front of that y squared. So we got 5y squared, my first term. Let's go plus 3y added to minus 3y. So 3y plus negative 3y is 0. They cancel. Now, if you want to write plus 0 here, you can. Just when you simplify your answer and get it all nice at the end, take it out. Right? And then finally, plus 4 added to minus 6. So 4 plus negative 6 is negative 2, so minus 2. We have underlined all of these terms. They have all been used. We are not leaving any term behind. So the answer to the original question about subtracting the first two polynomials, then adding the third one, is 5i squared minus 2. That concludes day one notes. Go back, look it over, follow along with it. I'll post the blank notes along with this video in Google Classroom. Take your time, make sure that you know how to do this. Use this when you do the practice. If there's any question, please let me know. Hope you're all doing well. Stay safe. Later.